because
Okay,
I did go to class on Monday and he was going over some of the rules. It's kind of iffy because he kind of already expects us like how to start some of these equations, and I still feel like I'm
sure.
not really caught
Let
up
me
or
grab, let me, if you don't mind, grab it, let me grab 7, 8, 9, just in
Mhm.
case
Okay.
we have plenty of time. I do kind of feel like we will, but,
Mhm.
um, okay. Uh, I'm all set. If you are to get started here on my side, let me share my screen and, all right, so let's look at a few of these.
Mhm.
All right. Um, okay, so right now you at some point learn that the derivative of natural log of x is 1 over x. But
Yeah.
the correct derivative is that the derivative of the natural log of u, just think of u as another variable, is
Mhm.
1 over u times u prime. So it is 1 over, it's 1 over whatever's inside the natural logarithm, but then
Mhm.
you multiply it by the derivative of the inside function.
Okay.
So you could treat this as the natural log of u,
Mhm.
where u is x plus 2. The derivative is 1 over u times u prime. And then u prime is the derivative of this thing over here to the right. What is the derivative of x plus 2?
Um, isn't it just going to be wait, X is just going to be at one and then two is non-existent. It's
Yeah.
just one.
So this
Yeah.
doesn't do much, but it's the right sort of feel that you're multiplying by 1, but it ends up being just 1 over x plus 2 as your
Answer.
final answer.
Okay. Okay, that's pretty simple then. Okay.
Any thoughts on that before we proceed to the next one?
um, so is the we have the log of X and like or like ln of U. Are these like two different rules that I should be able to
There,
apply and like use?
it's it's one rule, but it's simplified to this when you first learn it, the top one. But this
Okay.
is the more general form of the
Okay.
rule, and it's the better one to learn now that you've kind of been through it. But
Mhm.
you're not the first student to say, well, are they different? Are they the same? For some reason, it's just not made clear.
Mhm.
Um, but yeah, you want to think of it as almost in words though, like 1 over the inside function
Yeah.
times the derivative of the inside function.
Okay. Okay, got it. Yeah, that makes more sense.
So this one here, you can treat it as natural log of u, where u is x squared plus 7.
Mhm.
The derivative is 1 over u times u prime. Can you tell me the derivative of this on the right, please?
Yeah, it's going to be 2x.
Okay. So this is really 1 over x squared plus 7 times 2x. Simplified, it becomes 2x over x squared plus 7.
Got it. Oh, I got it. It's pretty simple.
And are you checking them as we go?
Yeah, I can just put them in.
Yeah, please do, just
Mhm.
as a precaution here in case I overlooked something or
Yeah. We do the first one. Let's see. Yeah, first one is correct, and then second one is also correct. Yeah, this one's good.
okay. So the third one here would be maybe one for you to try on your own if you want.
Yeah, let me
It's really
attempt.
it's a little
Yeah,
bit easier than the previous ones. So try
yeah.
that. I'll move on to number 4.
X plus 2. So- And the derivative would just be 3x or just 3.
Yeah, so you kind of already answered this with the first one. The
Yeah,
derivative of a number times x is the
x.
number in front.
Not this number is just 3, and then we don't include the 2. Yeah.
That's right.
So 1 over x plus 2. 1 and 3. Oh. Okay, I guess I'm a little stumped because we kind of moved really fast in the second one. I should have said something.
Yeah,
So
so
I
it's,
know, so yeah, I now know that the derivative is 3. So then
and
from
then
here,
well, it's the derivative is one over the inside part.
right? So 1 over
That's this part. And
part,
then you multiply by the derivative of the inside part.
which is 3
Yeah, so that's your final answer, 3 over
over
3x
3x minus 2.
yeah. Remember, you're the customer.
Mhm.
If I'm not doing a good job, tell me, hey, do better.
Yeah, no, I think I just get scared to speak up because,
Please don't. I mean,
yeah,
my responsibility is to serve, I'm providing the service. I want to make sure you get what you want out of this. So please always tell me, hey,
yeah,
didn't get it, don't know.
yeah.
Um,
Okay.
your verbal cues indicated everything was okay. Now your
Mhm.
nonverbal,
Yeah.
which I can't see,
Mhm.
I
Yeah.
would have a better idea. That is one of the limitations of this format.
Yeah.
You know.
Right.
Okay. So this one is really similar to the previous one.
Mhm.
We're going to rewrite this as e to the u, where u is x plus 2. Okay. And kind of off to the side here, it's kind of the same thing. The derivative d dx of e to the x is e to the x. You learned that, or that's in that reference sheet I sent you.
Mhm.
But what it really is when it's e to the u, the derivative is e to the u times u prime.
2 prime.
So in words, it's like this. It's itself times the derivative of the inside function.
Okay.
Okay, so the derivative is e to the u times u prime. What is u prime? What's the derivative of x plus 2, the
2.
inside function?
So x is just itself, and then, or we don't.
Tell me what to write here. Yeah, imagine I can't understand. Or I only know what to write.
Is it just 0? Or
What's
wait,
the number in front of x?
1. It's always gonna be 1. Okay, it's just
The
gonna be
constant.
1.
Yeah, it's the
Constant,
number that's in
right?
front of x. The derivative of 2 is 0.
0. So it's just 1.
Okay. Yeah. This is now you back substitute e to the x plus 2. See how that's the itself?
Itself, yes.
Itself. This is what you started with. If you don't like itself.
Mhm.
Times down here, the derivative of the inside function, which is 1,
1.
which doesn't change it,
Mhm.
but it could. I mean, a more complicated problem, it could.
So it is just e to the power of x plus 2. It stays the same. Okay. Oh,
Right. Is that okay?
yes, I understood that better.
All right. Number 5 is very similar.
Similar, yeah.
Going to be an e to the u again.
Mhm.
You're stepping through this very nicely in terms of like how to do this in a natural progression, where it's easier to sort of digest here.
Mhm.
So the derivative of e to the u is e to the u times u prime,
Mhm.
and you already have u.
You, right.
That's great, but you need u prime. You have to be able to calculate u prime.
Fine. So here it's just going to be 0 minus 1, which is just
Yes,
-1, negative
very
1.
good, very good.
Yeah.
So this time it is a little bit different. It's e to the 4 minus x
Mhm.
times -1.
1. Mhm.
It's not necessary for WebAssign, but just to make it pretty is to put the negative out in front.
1. Okay. Negative out in the front. Let me plug that in and see how that looks. Yep, that was correct.
Right, great.
Mhm.
Let's see what the next one looks like.
Mhm.
Darn, you don't get another one here. Let me give you one real quick just to see
Mhm.
if this makes sense.
Yeah.
Could you take the derivative of this, please, for us?
Yeah, let me do that. E- Two. Okay, I think I'm stumped on the last step on how to write the final answer. So I got the derivative as 2.
That's the derivative of the inside function. So it's
Is
e to the
2. Yeah.
u, where u is 2x plus 5.
Yeah.
The derivative is itself, that's the itself,
Oh, okay.
times u prime.
So that would be. So that would be e2x plus 5 times the 2, or
Yes,
yeah,
exactly. Yeah, times
yeah,
2. And then it's better if it kind of goes in front. So you'd write 2 e to the
2
2x
e
plus 5.
test. Okay, yeah, okay, that's exactly what I got. Okay,
Fantastic. Okay.
this took me a second. So you would move whatever you're multiplying to the front of the like letter or like exponent.
Yes.
Okay. 6. Okay, we could try one more.
Let's move on.
Okay.
We gotta make sure we get through everything. Let me check the
Yeah.
the other questions. Oh
Yeah.
boy. Um, oh, I take that back. Why don't you try 8? 8. I'm gonna snip it in.
8.
But
Yeah.
8. That's why I like having all of them, because I can then say, oh
Mhm.
yeah, there's a good one for us to try. It actually would have been better than the one you just did,
Mhm.
because it's signed, just like the one you just did.
Yeah. So. Yeah, so I got 4e to the power of 4x plus 9.
Exactly. Very good.
Okay, got it.
Right. All right, so let's go to number 6 whenever you're ready.
Yep, ready.
All right, so this is a product rule problem.
Mhm.
And you have to recognize that from the beginning. You have to realize that, okay, there's a separation here.
A
This is,
product rule. Okay.
and I'm gonna use U and V. I don't know if I used that before, but I kind of prefer
You
that. But if
did,
you
yeah.
roll, and that, it's kind of consistent with that whole like U thing that I've been doing earlier.
Mhm.
Um, there's a method, there's a reason for all the things that I do. Um, now, you as a student have to be able to take the derivative of each of these, without question. So I'm gonna put a 1 there. Could you tell me the derivative of U and or V?
Yeah, u is just going to be 12.
12x. So remember, you
12x.
subtract 1 from the exponent when it's more than 1.
One, more than one.
So
Okay.
it's really 2 minus 1, but it's 1. You remember that from
Yes,
before?
the product rule. Yeah. You subtract, yeah. Okay, so 12x and then v prime. Um, it's like wait, I'm looking at the chart. I think well, it's anything to it's wait to x. It's just one.
Or minus 1?
1 minus 1. Okay. And that's because of the product rule.
No. This is pure polynomial.
Okay.
So the reason the first one is 12x is equal to 2 times the 6, 12
Oh,
x. That's why this first one was 12x. For the second piece here is like the ones that um we were doing.
mhm.
Um,
Okay.
it's just the coefficient.
Okay. Yeah. Okay.
These are great questions. Please ask these. I mean, this is the clarity you're trying to attain in this lesson here. So what about the derivative of natural log of x? Do you remember that?
Not really, if I'm being honest.
So we just did that earlier. Remember how I made this whole comment about, well, it's like x, it's either x or it's u, so 1 over x. I would definitely recommend printing out that reference sheet. I'm happy to resend it.
Yeah, I have
You really
it.
want,
Yeah,
you
I
really
can
want to have these rules, kind of your
down.
cheats.
Yeah. So it's gonna be 1/x for the natural log.
Yeah. So now the derivative is which is the first times the derivative of the second plus the second times the derivative of the first. Basically you're pairing up the original function of one with the derivative of the other, the original function of the other with the derivative of the other. Yeah.
Yeah, like the
Basically
cross
you have to
multiply.
one and one. And then the order
Yeah.
doesn't matter. If you want to remember it another way, um,
Yeah, no, this makes sense. I got
yeah,
that.
yeah.
Yeah.
So this is, and the teacher doesn't care how you write it.
Yeah.
Now we'll get to another issue here, but this is your answer. However, um, all right, so
I think it, okay.
you can, this will, like, WebAssign will take this, but if you're in your
Mhm.
by hand test though, you'll want to simplify, like the X cancels each of these X's,
Mhm.
but that's a small thing. Um,
I'm checking web design. It didn't take what the non-simplified version.
okay.
Yeah, I can share my screen.
Now let me just take another look here. Sometimes I
Yeah.
get to that times that plus. Yeah, I mean, I think you just need to simplify. Um,
Okay.
like this should take this next line.
Could you go over how you simplified that again?
Yes. So it's 6x squared over x minus x over x when you multiply that in. So you can see
Mhm.
the x squared cancel with the x to get down to x over x because they're the same becomes 1.
One, right? Plus, got it. Okay.
Uh,
Let's see, 6x plus. Yeah, it still did not take that.
yeah, why don't you quickly share your screen, try to help you navigate. Maybe I'll see something that
6x plus 1 minus, oh, sorry, minus 1 plus x.
no. Click on practice another there in the top right. And just hit 1, put just the number 1 in there and hit check,
In here.
type 1, yeah. And then do a show answer. All right, so there's the format they want.
Mhm.
So you have to make yours match that format.
Okay.
So type in 6x, and I don't know if it'll stay up once you start typing in there, but so yours will be 6x squared minus x in the numerator.
Mhm.
You're gonna have to highlight, yeah, or you start with that, yeah.
Over.
And a lot of students do use this, put it over x, yeah.
Mhm.
X, yeah.
Yeah.
Plus parentheses 12x minus 1. Close parentheses, natural log of x, no parentheses. So a lot of students will pattern the answers doing this. You
Yeah.
don't learn anything, but it does work if you're short on time.
Does it matter if I do it like?
I would just follow their format. It shouldn't matter, but we already saw that it seems like it did matter. So, I don't make the rules. Just
Yeah.
hopefully that works. No, wait, that's the issue. That's you typing IN. It's LN,
LN.
lowercase. There it is.
Yeah.
Now that probably was the issue. I probably didn't see that the
Hmm.
first time. Because it should take both.
Yeah.
There we go.
There
All
we go.
right, very good,
Gotcha.
excellent. All right, I'm gonna go back and share my screen here.
Mhm.
At the 30 mark, when I'll move to the other thing that you wanted us to work on?
Yeah.
Just to make sure we get everything done, but
Yeah.
a couple more problems here that we got good for us to work through together here, starting
Mhm.
with, actually, let's go down to the story problems, number 11.
Mhm.
These can be sort of frustrating.
Yeah.
All right, the total spent on research and development of the federal government can be approximated by this function. Where T is the year since 2000, what was the total spent in 2005? T equals 5. So
Mhm.
for this first problem right here, they're just asking you to define S of 5.
Mhm.
Go into your calculator, times natural log of 5 plus 22. Just like that. Round your answer to nearest whole number. So I guess it's going to be, well, natural log 5 is not that big. I mean, it should be like, I would say like 29 maybe or something. It's not going to be super big, but if you got a calculator handy, please do that. I'll do
Yeah.
the same.
Oh, the one, yeah, I got, yeah, 26.98. So we'd round it to 27.
Yes.
Yeah.
For part B, it's asking for the derivative.
Mhm.
We shouldn't be surprised by that. If you're
Yeah.
ever not sure what to do, you could think, oh, I should take a derivative.
Right.
So the derivative in this problem is 3.1 times 1 over t plus 0. So the derivative of natural log of t is the 1 over t. The
Over
reason 3.1 comes along is it's a constant. That
constant.
constant in front always just comes along with it. When you're adding a constant, that's when the derivative is 0.
0. Yeah.
Okay, so now we're going to put in the 5. We're going to put in the 5 for t.
Mhm.
So it's 3.1 divided by 5. And then we're going to round that to 3 decimal places.
Mhm.
I don't think we're going to need. I think it's just 0.62.
Yeah. Yeah, and this was similar to the marginal cost problems we're working on. It's always going to be
Exactly.
derivative is the second part. Yeah, I remembered that. Okay.
Okay.
Yeah, got that. That was good. Looks good.
Fantastic. So, sorry, now I'm up here. I got to find the next one. Let's go to number 12.
Mhm.
Number 12 here. All right, if $20,000 is invested in a savings account offering 3.5% per year compounded continuously, what is how fast is the balance growing after 2 years?
Mhm.
So this is a PERT equation, PE to the
Yeah.
RT.
Yep.
It's the initial amount that you have, E, your interest rate as a decimal
Mhm.
times time. Okay,
Which is
so
2 years.
yeah, we'll get to that in a moment. Like if it wanted the balance after 2 years, we would definitely put 2 in for T.
Mhm.
Because it's asking how fast is the balance growing? How
Mhm.
fast is the balance growing? That means derivative.
Okay.
That's your cue that it's derivative. All right. So the derivative of this is the constant comes along with it. The derivative of E is itself.
Mhm.
But then you have to take the derivative of the inside function, which is 0.035.
Okay. 0.
So then we have to evaluate the derivative at 20,000 e to the 0.035 times 2, 0.035.
Okay, gotcha. Then we would type all of this into the calculator. Mhm. To get the E symbol, is it uh second? Wait.
Isn't it TI 8384 or something else?
Oh, yeah, it's a TI 84.
Okay, so that's under ln on the
Mhm.
left there. You
Yeah.
can see this the second. You may want to use parentheses also for your exponents.
Yeah. And then is there an wait option to change it? So I have the LN button, but to get E
You have
is
to, you have to hit the second button first, the
second
yellow
and
one
LN.
in the
Yeah.
top left. Yeah,
Yeah,
and
got
then
that.
I'll give you an E.
Yeah. So two times. So I got 750.75.
I got the same. Does it say what to round to? I don't have that here.
It said round to the nearest cent.
Okay, that does help.
Yeah.
Yes, so I got, it would be 70.750.76 when you're out to
For
nearest cent.
rounding it. Yeah.
All right, so there's plenty of questions to come back to, but let me go to that second grouping that you
Mhm.
found here.
Mhm.
That's an important,
Yeah.
that could take the rest of the time potentially, so we'll make sure we get through all this. Oh, boy. All right. This is beyond the scope of what you've been doing a little bit, so some of this probably will not be clear, but
Mhm.
we'll do our best. Hang on a second, Sophie, I'll be right back with you.
Yeah.
All right, I'm back with you. So this first one is going to be a U, and the second one is going to be a V.
Mhm.
So we have U equals 2x plus 1 to the 10.
Mhm.
V equals x squared plus 1 to the 10.
Mhm.
Okay, so these are considered chain rule problems
Mhm.
right now. They're power rule followed by chain rule. So let me just show you the derivative rather than, and you can ask questions. So the first thing
Mhm.
is you bring the exponent down. So it's 10,
10. Mhm.
2x plus 1 to the 10 minus 1 power. Do you
Yes.
remember us doing that? Okay.
Yes.
Then 10 minus 1 is
Fine.
9.
Mhm.
Okay, we'll get to that. But then you have to take the derivative of the inside function. The derivative of the inside function is just 2.
Mhm. Okay.
All right, so now we have v prime on the right, same thing here. We're going to bring the 10 down,
Mhm.
x squared plus 1,
Mhm.
10 minus 1. We're going to take the derivative of the inside function. Now, the derivative of x squared is 2x.
2x.
So u prime is 20
Mhm.
times 2x plus 1 to the power of 9. V prime is 20x, x squared plus 1 to the power of 9. I'll be
Mhm.
right back with you. Right
Yeah.
back. Okay. So any questions on those derivatives
No, I
from the,
understood all of this.
okay.
Yeah, I got that.
Now back to the kind of the original part, which is the derivative of the original in terms of u and v is u v prime plus v u prime, like that.
Mhm.
That's the kind of that standard rule. And now we're just substituting in for those things. So u is the 2x plus 1 to the power of 10.
Okay.
V prime is the 20x x squared plus 1 to the 9th.
Got that. Yeah.
V is the x squared plus 1 to the 10th. And then u prime is 20 times 2x plus 1. I left a 1 out, the power of 9 there.
Mine. Yeah, got that. Okay, got it.
Okay, so this is correct. You can simplify a bit more if you wanted to. It doesn't say to, so I wouldn't.
Yeah.
If you want to be like the A+ student all the time, you would do that, but this is probably sufficient.
Mhm.
You
Yeah,
do
this
maybe
should-
want to send an email or ask like, hey, is it okay if I leave it unsimplified or not?
Yeah.
They didn't really say, so,
Mhm. Yeah, I think that should be good because
okay. All right.
okay, that wasn't too bad. Okay, got it. And then there's
All right. So part B,
Mhm.
part B here. So this was a kind of like the previous one in some regard. Uh,
yeah.
we're gonna really call it, we're gonna say this is really u squared, where u is the natural log of x.
Right. Okay.
Okay, so we're
Yeah.
just making a substitution again.
Mhm.
So the derivative of of u squared is 2u to the 2 minus 1 power. You bring that exponent down times u prime.
Prime. Yep.
So what I'm hoping you're seeing is that whenever we make this substitution, you always have to take the derivative of the inside function.
Yes.
All right, can you tell me the derivative of natural log of x from earlier?
1/x.
Yes.
Yep. And then
All right, so now this is 2u times u prime. So we just substitute those in 2 natural log of x
Mhm.
times 1 over x.
yes.
Since this one's not that difficult to simplify, you could rewrite it like this.
Yeah. Yeah, that was easy. Got that. Yeah, got that.
All right, is that okay?
Yeah, that was easy. Yep.
All right. Part C is odd, because you guys haven't covered
I
this
haven't
yet.
really covered this yet, so I'm not really sure why this is on here.
Um, do you remember hearing the word implicit derivative anywhere in class?
Very briefly, but
Your
we
teacher
haven't
did
really.
talk about that though, is that right?
Yeah.
Okay. Reason I ask is because there's a couple ways to do this. One is to use implicit derivatives, which I think is what was the intent, but
Hmm.
we'll put kind of another shortcut here.
Yeah.
All right. So this is gonna be really weird, but just I guess follow along here. I'm gonna first
Mhm.
actually switch the sides for the moment.
Mhm.
All right. So on the left here, if this were an x instead of a y, what would the derivative of x squared be?
Just two.
It'd be 2x.
Two
Okay.
X. So why
So
is it different compared to the other
it
rule?
has both an x and a y in it.
X and a Y. Okay.
Yeah. Now, whenever you have a derivative with respect to y, you have to add in what's called a dy. Yeah. So
Okay.
you treat y like an x. That's why the derivative is 2y,
Two Y.
but then you always multiply by dy dx.
Okay. dy X. Okay.
Now on the right, it's more difficult because it's product rule. That's why I, didn't really like, but that's okay.
Mhm.
The derivative of y, let's just say it was an x. It was 1x. What would the derivative of 1x be?
Just one.
1. So this derivative, this is 1 times dy dx, because y always gets a dy dx.
Okay.
V prime is 2x.
Mhm.
Okay. So now product rule, u times v prime plus vu prime. We're taking the like the u with the v prime, or the v with the u prime. So it looks like this: y times 2x plus x squared times dy dx.
Yeah, got it.
Okay, now we're trying to solve for dy dx. Actually, you can make a note to your instructor that they used what are called partial derivatives here, which is not the right one for this course.
Okay. Yeah, I
Um,
agree with that.
so you could actually maybe get some extra credit there. Uh, Anyway, so the next thing is to solve for dy dx. So you want to move them over to one side. So I'm going to subtract this from both sides, and the calculus is done now. There's no more calculus,
Yeah.
but this is necessary to do. 2y dy dx minus x squared dy dx equals 2xy. It's just changing the order here
Mhm. I see
and
that.
moving this over. So now you factor out a dy dx, 2y minus x squared equals 2xy. And then so that dy dx is factored out of both. And then you divide both sides by 2y minus x squared. 2y minus x squared.
Yeah, I'm just giving a second to like process it, look at it. So we subtracted it from both sides and we're wait, why are we dividing 2y minus x squared?
We want to solve for dy dx.
dy dx, find dy dx. Okay, so we subtracted it from both sides like you would do in an algebra thing. You're at this step, and then from so we're taking out dy dx, the outside.
Yes. Factor out.
Mhm.
dy dx.
X. So then we're just left with that. Oh, so that we have dy dx on the left side, and then we have our answer. Right, we're bringing that. Okay, okay, got it.
All right. There's your answer.
Yeah, okay, got it. Perfect. Okay.
That's so we have what we have not done. Don't think we've done 7, so we'll go back and start with 7 and that gives 9. So all right, so find the derivative of the function. So this resembles slightly what we just did, or parts A and B.
Right.
And this is another U and V problem. It's a product rule.
Yeah.
U equals x plus 2 to the 0.5 power. V equals natural log of x. U prime here. So this one's got a little bit more to it. It's a power rule. It starts with the power rule. You bring the power down. So it's 0.5. Keep the inside function. Subtract 1 from the exponent times now the derivative of the inside function. The inside function is x plus 2. Its derivative is just 1. So with a little bit of simplifying here, you get minus 0.5 as the exponent.
Yeah.
Okay, it's kind of off to the right here. V prime is just 1 over x.
Yeah.
So now your product rule pairs up an original with a derivative of the other.
So
and the order doesn't really matter. So this again, so just make sure when you enter this, it's ln. That was the issue last time. But so we got x plus 2 to the 0.5 power times 1 over x plus natural log of x times 0.5 x plus 2 to the minus 0.5 power.
Yep.
You're just collecting things. You're not really doing any
putting
math
it together. Yeah.
Yeah.
X. Yep, that looks good.
Number 9. Going backwards slightly. So this is really e to the u. And u is this long thing, 2x squared minus 5x plus 9 divided by x, like that.
Okay.
So from earlier, we said, okay, the derivative of e to the u is e to the u itself times the derivative of the inside function. I'm just going to slightly rewrite the inside function here. That last one, we're gonna write it as 9x to the minus 1 power. And that will make it easier to apply the derivative rules.
So the whole inside of the function is everything that's to the exponent.
Exactly.
Okay, got it. that big.
That's your U.
Yeah, you.
So your derivative here, U prime.
Mhm.
Can you tell me the derivative of 2x², please?
4x,
Okay, good. Minus, what's the derivative of 5x?
just 5.
Good. The last one here, you bring the exponent down, so it's -1 times 9 x to the -1 power,
Okay, let's see. For
which
this.
becomes -9 x to the -2 power, like that.
I got it.
All right, so the derivative here is e to the u, e to that original thing, 2x² minus 5x plus 9/x times u prime. U prime will be in parentheses. 4x minus 5 minus 9x to the -2 power, like that.
Yep, got it. Oh, okay. And
And should accept all that, so please,
yeah,
take a look. Let me
yeah,
know if it does not.
yeah, I'm typing that in right now. Let's see. Oh, it's a little tricky with the double exponents. Let's see. 2x to the power of 2 minus. Yep, it took that.
All right, last one here, number 10. All right, so number 10, it's kind of like two problems in one. First thing is this 2e to the x, the
Mhm.
derivative of that. The derivative of e to the x is itself, and
Right.
then you always bring down the constant. So that takes care of that first part. Like it's just itself, which
Itself. Okay.
isn't all that, Great. Now the second one here is a product rule. So it's u is x², v is e to the x. Okay.
Mhm.
And the reason this big parenthesis here is because when we take the derivative of this, it's all being subtracted. So we're gonna put what's inside here and then give the correct sign.
Mhm.
You still break it up as product rule though. So what is u prime? What is v prime? Can you tell me either of those, please?
2 for u prime, and then
Do a little bit more, a little bit more.
uh, x,
2x, yeah.
and then v prime. Is that going to be like just 1, or is it 1x?
The derivative of e always starts with itself,
Oh,
e to
so
the x.
e to the x. So it just
And then if there is an inside function, which is this exponent, you would take a derivative of it, but there is none.
nothing, right?
So you're just pairing up diagonally. This is kind of the cleanest one we've seen. x² e to the x plus 2x e to the x, like that. And then it's up to you if you want to distribute this negative. If you were to like use an online derivative thing, it might factor out something or put the negatives. It might rearrange this a little bit, but it's the same thing.
Yeah. Yeah,
All
that
right.
looks good.
All right. Anything else you'd like help with today?
Yeah, that was everything. Thank you
Awesome.
so much. That was a really
Yeah, of
big help.
course. Of course. Always